they're using a tilt-a-whirl to simulate gravity.
Wait, if it's like a tilt-a-whirl, wouldn't the fat guy fall out first?
Maybe we could simulate it on Earth and try to overcome the Earth's gravity.
Well, there's only two people we can ask. Future Grant and Andrew.
Well guys, we can figure that out pretty easily using the force equations that we know.
To find when the centripetal force will overcome the force of gravity, let's look to the top of the wheel, where the force of gravity will be most direct. Now first, we'll set these equations equal to each other. From this, we can clearly see that the two masses cancel out.
Oh, so a person with greater mass wouldn't fall out first in that kind of environment.
That's right.
Oh, so now all we need to do is build a wheel that can mimic that machine, and then just have a known radius and we can solve this equation.
That's right.
Alright, it's taken one epic montage, but now we finally have our wheel. The radius of this wheel is 35 centimeters, so how fast are we going to need to spin this, Future Grant and Andrew?
Well, now that we know that the radius is 35 centimeters, all we have to do is substitute it in and we can get the equation it needs to be moving at. So now we know that the bolts must be moving at 1.866 meters per second. Or we could also use calculations to figure out how fast it has to be spinning.
By finding the circumference of the wheel, we can next determine how many rotations per second we have to spin the wheel to keep the bolts from leaving.
Oh, so no matter how much the bolt weighs, something inside of that wheel will fall out once the wheel is spinning at 0.836 rotations per second. So Andrew, all you have to do is get that wheel spinning, let it slow down, and when the bolts fall out, we'll know that they were all falling out when the wheel was at that speed.
Alright, we have your calculations. We've got 3 nuts in here of different sizes and weights. Now let's give it a spin and test this theory.
Well, there you have it. As you can see, everything fell out of the wheel at the same time. This proves that when you're canceling out the force of gravity with centripetal force, that mass still does not matter.
Thanks for watching.